We start this new unit on polynomial functions with an introduction to the standard format of a polynomial function. So we need to understand what the standard form is and all of the different parts that go with the standard form. Now, at this point in the year, through Algebra 2 and Algebra 1, you should have worked with at least 2 or 3 polynomial functions at this point and should be kind of familiar with the format. But let's just talk about a few of the pieces that goes along with the polynomial function. So you can see here this generic form. We have lots of variables going on here: a to the n, x to the n, plus a n minus 1, x n minus 1, and down all the way a to the 0. And so that can be a little bit confusing unless we, say, put some numbers in it. So what I'd like to do is just kind of give you a few examples of what we're talking about here. So if you look down here at the common types of polynomials, you can see we're going to have a constant, a linear, quadratic, a cubic, a quartic. And so we have the standard form written with all the a's and the b's and the x's and the zeros and all of that stuff. I'm going to go ahead and give you an example of each, just simply with numbers and how you would normally see it in a problem. So the first one is a constant function. A lot of times people don't think about the constant function being a polynomial function, but it actually is. And what defines the polynomial function is the fact that we have a variable that is written to an exponent that is a whole number. Sometimes you'll see in textbooks say that it is a positive integer, which is basically a whole number. Well, the variable that has a whole number integer in this case is an understood x to the 0 power. And if you recall, x to the 0 power is equal to 1. And so since x to the 0 is equal to 1, we tend not to write it. So f of x equals 4, f of x equals 2, f of x equals negative 3. These are all constant functions. Now, hopefully you remember that a constant function gives you what we would call a horizontal line. And so anytime you see f of x equals to just some singular number without the variable there, we're looking at a horizontal line. Then we moved into linear. And linear was something of this nature. Say f of x equals 2x plus 1. And so again, the constant value, would have an x to the 0 power that's understood. Now, a lot of y'all learned this as y equals mx plus b, or the slope-intercept form. And this is just a standard form of a linear polynomial. So the reason it's linear is because its degree is at 1. And so you can see here the highest exponent value for the variable is what we would call the degree. And that degree is going to tell us a number of things. It's going to tell us how many solutions the polynomial has, which is also going to tell us how many zeros or how many roots we're dealing with. And so you learned how to graph linear functions. And then as you moved further into algebra, you got to quadratics. And we just finished our quadratic unit, and say its standard form would be x squared plus 2x plus 3. And we can see that this has a degree of 2 because the highest exponent value is 2. And we can continue to just build these. So x to the third, x squared, x, and we could write it like that, and that would be a cubic. And of course you can see that our highest exponent, or our degree, is just building up higher and higher and higher. And so we tend to call lower level polynomials various names. As we get higher into the degree, we tend to just call them by their degree. And so we might call a quartic a 4th degree polynomial. Also, do not be confused with monomials, binomials, and trinomials. The amount of terms in them just doesn't define what type they are. It just tells you how many terms they are. Monomials and binomials and trinomials are all forms of polynomials as well. So we have a number of things going on here. When we write the polynomial function in standard form, with the degree value, or the highest exponent value, written at the beginning, we have a coefficient that is attached to that variable. We call that coefficient the leading coefficient. And so you need to be familiar with the leading coefficient. You also need to be familiar with the constant values. Now, If we have a leading coefficient that's not there, it's an understood 1 if that x does not show it. So these are just some of the basic terms and the way the right polynomial functions in standard form that you need to be familiar with. So also understand that the degree indicates the number of solutions or the root, and solutions, roots, and zeros are basically interchangeable. Alright, so that's a good start and introduction to polynomial functions.